There we are.
Good.
Okay.
Okay.
We're good.
Good. Terrific. So, good evening, everybody. For those of you that might not know me, I'm Lauri Roche. I'm going to be your host tonight. I think I've only done this ever one other time. So I will be asking for help from all kinds of people who do it all the time. And if I miss anything, please chime in and let me know. I would like to just kind of start. I know it's not usual, but I would like to start to say that I am very happy to acknowledge that I live and play on the lands of the Wasanic people that live here on the Saanich Peninsula, and they belong to they have been here for millennia, and we're in the Gulf Islands and up on the Saanich Peninsula, and I get to not only live here and be close to their places where they live and work, but I also get to be up at the center on their territory as well, and really enjoy being there. So I thank them very much. I'd like to welcome people today, and I'm wondering if there's anybody that is new, either online or up at the center, or up at, sorry, not at the center, up in Fairfield. Is there anybody that doesn't know anybody? No? Okay. Is there anybody online? I can't see absolutely everybody online, but is there anybody that is fairly new? Nobody's coming up here. I don't really hear anybody saying anything. Megan, you've been here before, right?
Yes.
For sure. Yes. Okay. I recognize. And Carlos, Carlos, I recognize. Yeah. Okay. Well, if anybody does kind of come in, let me know, and we can say welcome and thank you for coming into the Astro Cafe for Monday, November the 4th. I have asked for people who would like to make any kind of presentations or any announcements, and I have Randy, David Payne, Alex, Peter Jedicke, and I know that if David Lee comes in, I know that he had a couple of things about the SIGs. And is there anybody else? I will be talking a little bit about some resources for cloudy days or cloudy nights, and we will bring in some other people into that presentation, including Natasha. Is there anybody else that has got anything that they would like to announce or present to us tonight? Okay. Well, just let me know if you do. That's not a problem. Um, I'm going to start with Randy. Randy's got a presentation which I kind of gave him a little bit of a nudge for. I was supposed to give a presentation on travels in Italy and going to some of the museums that I went to. And I'm sorry, but I have been completely and totally overwhelmed with finishing off some Nova stuff, and I just didn't get a chance to finish it off. And I didn't want to do it when I couldn't do it well and properly. So Randy is going to fill in for me, and I will do that presentation another time when I am fully ready to do that. So Randy, you can take it away.
Okay, thank you. And yeah, so I asked Lauri if there was anything that she was keen on that I talk about. And oh, I have to share. That's silly. Hold on.
Yeah.
I haven't shared yet. And so she said, tell us about how the moon was born. And I thought, easy, because I always think everything is easy until I actually get into it. And it wasn't easy. There's a lot to this subject. And
Randy, I'll just interject by saying what I wanted was, I mean, I know there's theories, but I wasn't totally sure of some of the evidence for those theories. And so
Right.
that's what I was kind of looking for. So okay.
So the word is selenogony. So Selene is the goddess of the moon, and when you have goni at the end of a word like theogony, it's how they were formed. So theogony is where the gods came from, for example. Let's start with Rodin's beautiful sculpture where we have, I guess that is Gaia at the top and Diana, another god of the moon, underneath, coming and forming from a kiss, which is just a lovely metaphor. Anyway, so let's talk about what are some of the interesting aspects about the Earth-Moon system that one needs to explain in order to say where the moon came from. So when you compare to all the other planets, except kind of Pluto, but that's a whole different case, our moon is huge compared to the planet. That does not mean that our moon is the largest moon in the solar system. What is it? Ganymede and Titan and Callisto, I'm going to guess, are actually larger. But, you know, our moon is still, it's bigger than, for instance, Mercury. So it's huge. The angular momentum, we're not going to get much into angular momentum, but I'm going to say that the Earth-Moon system is spinning around like crazy, and most things in the solar system spin around close to a single plane called the ecliptic. And the idea is that early before the sun even formed, the cloud of stuff that gathered together gravitationally all got kind of pushed down into a single plane. And so we get pretty well everything that's spinning, except for some exceptions, are spinning in that plane. But then the Earth is off by 23 degrees, which is good for people who like to have windy autumn days and nice bright summer days. The seasons happen because the Earth is tilted to the ecliptic, but the moon isn't. I mean, 5 degrees, but it's not 20 degrees. Okay, the big one, which of course nobody knew about until the 300 or so kilograms of rocks was returned to Earth since 1969. But the moon is very, very similar to the Earth. When we're just looking at the chemicals, the elements, the moon has much, much less iron than the Earth. In fact, the Earth, 6,000 kilometers in radius, the first 3,000 kilometers is our iron core. Whereas it's the proportion of the moon that is its core is much, much smaller. But the other thing is that the moon has less of the volatiles, the molecules and elements that are low boiling point, and so they would just fly off. Okay, and that's fine, but the big thing is that it is hard to distinguish the moon's isotopes from the Earth's, and we're going to talk about isotopes later on, but this is the different types of atoms that have the same chemical nature, okay? And they're shockingly similar. So those are the things you want to explain. And there are 4 main models, and I'm going to go through each of these, and then we're going to also end off with 4A, which is a different type of impact. But I want to show you my lovely 3-volume book about everything about the moon by Garfinkel. It's called Luna Cognita. It's just a wonderful resource. And he went through the different versions very nicely. And then this is another great book by Patrick Moore, the great British amateur astronomer. And he quotes Harold Urey. Who's Harold Urey, I hear you ask? Nobel Prize for discovering deuterium, heavy hydrogen, but also he invented the term cosmochemistry. And while the Apollo mission, I think pretty clearly was a propaganda machine, it was because of Harold Urey that they had a science program. He's the one that pushed NASA to actually get the manned mission to the moon to have a heavy science program. Awesome fellow. And this is what he said. Harold Urey once made the caustic comment that because all theories of lunar origin seemed unlikely, science has proved that the moon cannot exist.
Well done.
Anyway, the interesting thing is he was very much of one camp, and when the samples came back from Apollo, he totally changed. He realized that he had to change his understanding of the moon. And he wrote the book in 1952 about planetary geology. But when confronted by real evidence, he had to change. Okay, so condensation, or the nebular hypothesis. And this is where the Earth and the moon are sisters. They grew up together. And interestingly, you can actually trace it back to René Descartes. But way before they even knew about gravity, like people knew there was gravity, but there wasn't the universal law of gravity until the end of the 17th century with Newton. But he had this idea of vortices forming around the sun. Then, quite independently, the philosopher Immanuel Kant and the mathematician Pierre-Simon Laplace, using Newton's idea of gravity, formed this nebular hypothesis. It's often called the Kant-Laplace nebular hypothesis. And in it, you get these concentrations. Most of the matter of the solar system is in the sun. But way off in the fringes, you get these little gravitational clusters, and out of that, you get the planets and their moons. And then, very important in this story, you've heard of the Roche limit, where if a satellite gets too close to a planet, it will break apart and turn into something like the moon, the rings of Saturn. He was very much one of the developers of the nebular hypothesis. And very important, Carlo Shapley, who we know as, he's the one who thought that the spiral nebula were inside the Milky Way. And he was the one who argued, saying that the Milky Way was everything. There was nothing outside. Anyway, he was the head of the Harvard Observatory after Pickering. And he was very big in developing the nebular hypothesis. But it kind of has a trouble because there are these differences between the Earth and the moon, the iron, the volatiles. And so it doesn't satisfy all the constraints that we have. Also, doesn't really explain why there is so much angular momentum, so much spinning going on in the Earth-Moon system. Okay, so instead of sister planets, maybe the moon is a daughter planet. And interestingly, this started with George Darwin, Charles's son, who was a geologist. Charles was also a geologist, by the way. And he had this idea that when the Earth was young, it was spinning around really, really fast. By 1878, they knew that the moon was receding from the Earth. Looking at the ages of solar eclipses and things, they had worked out that the moon is receding from the Earth. And so he worked back and he said, well, 50 million years ago, long time, 50 million years ago, the moon must have been right next to the Earth. And so there's a contradiction there. Now, the calculations in the 19th century weren't like it's now. It was a lot longer ago that the moon was was close to the Earth. But with the data he had in 1878, he figured 50 million years ago, the moon was actually part of the Earth, and the thing was spinning around so much, and with a funny resonance with the sun, we got this kind of tongue sticking out from the Earth, and it pulled away, and that was where the moon formed. And then Osmond Fisher said, oh, and there's a scar. We still see it today. It is the Pacific Ocean, because they're about the same size, right? And then William Pickering, so remember, Edward Pickering was the head of the Harvard College Observatory, did all that amazing stuff with the classification of the stars and everything. Anyway, his brother William was really keen on the moon and Mars and all that. And he thought when the moon left the Pacific Ocean, then that also led to the Atlantic Ocean cracking apart. And that's why you get that beautiful coastlines match between Africa and South America. Okay, so he figured that was the cause of that huge rift in the Atlantic. Beautiful. So this was the main model before the Second World War. And it was in the Moore book about the moon that he quotes this 1936 radio script. So it starts, I'm going to read this out because it's too fun. It starts with a weird mysterioso fanfare. And then the friendly guide says, have you heard that the moon once occupied the space now filled by the Pacific Ocean? Once upon a time, 1 billion or so years ago, when the Earth was still young, a remarkable romance developed between the Earth and the Sun, according to some of our best scientists. In those days, the Earth was a spirited maiden who danced about the princely Sun, was charmed by him, yielded to his attraction, and became his bride. The Sun's attraction raised great tides upon the Earth's surface. The huge crest of a bulge broke away with such momentum that it could not return to the body of our Mother Earth. And this is the way the moon was born. And the girl responds, how exciting. This is real. This is not making it up. Okay. So that was fission. Then somebody who rejoiced in the name of Thomas Jefferson Joseph C. said, well, maybe there's something in the solar system, a resistive medium that slows things down and helps getting things into a plane. And the trick is it's very difficult to capture an object in flying through space. If there's no friction, then either it collides or it spins past and you get a gravity assist. There's nothing really easy. I mean, it happens, like Phobos and Deimos, these two little moons of Mars, are quite clearly captured asteroids. So it does happen. But to get the moon to be captured by the Earth, you got to have something slow it down. And it's not easy. And then also, yeah, why the close similarity with the Earth? Why are these two independent bodies so similar? It's kind of weird. So then we come to the giant impact, which Lauri tells me she likes to call the big splat. In Garfinkel's book, he calls it the big whack. Anyway, this, not the same theory, but Buffon was a great French biologist who, among other things, discovered a dinosaur and had to try to explain that back in the 18th century. Anyway, he thought that a comet could have struck the sun, and the impact of that created the planets and the moons and everything. Anyway, let's go on to some more modern interpretations. So Reginald Daly, a great Canadian geologist, but spent most of his years at Harvard, and was one of the early proponents for continental drift. So in my world, he's one of the heroes. And but in 1946, he recognizing that all those other classes of models were deficient, he proposed in quite some detail that there was an impact. Okay, early on in the Earth's history, a Mars-sized asteroid, and I don't think he named it Theia. I should find out who actually named the impactor Theia, but something about Mars size banged against the proto-Earth, and the interesting thing with the model is that it had to be at quite a steep angle. They think around 45 degrees, and that would have been enough to tilt the Earth on its axis. It would have sampled, you know, the Earth is, the inside is its iron nickel core, and then there's 3,000 kilometers of mantle. Mantle is an interesting rock because it's the stuff that didn't go into the core and didn't go into the crust. It's what's left over. And it is depleted, is the word we use. Okay. And the moon is very depleted. It doesn't have all of these things like creep. Creep is potassium, that's the K, rare earth element, phosphorus. Anyway, the moon is missing creep, it's missing iron, and it looks very much like the Earth's mantle. And so the idea is that this thing glanced off the Earth, vaporized a whole bunch of the Earth's mantle, and created a cloud around the Earth, which formed into the moon. And there's some people who say it happened over millions of years, and some people say it happened over hours, but it's basically, you know, that's the whole story. And then the most influential paper after Apollo was Hartman and Davis in 1974, where they did all sorts of models and things, said that it had to be Mars-sized, and they could tell you all sorts of things about the angle of the attack and what happened afterwards. So when we talk about the giant impact, we mostly are now referring to the Hartman and Davis paper in Science in 1974.
I noticed you have not mentioned Velikovsky.
I didn't. I read about him and I didn't really know what to say about him. Do you have anything to say about him?
No, definitely not.
He gets talked about, but I don't know what he actually contributed.
I don't think he contributed anything to substance.
Oh, so my reading was correct. Okay.
But he's a very interesting guy.
Okay, so origin of the moon as per giant impact hypothesis, simple model. So we have a proto-Earth and Theia. Why Theia? Theia is Selene's mummy. Okay, so Theia impacts the Earth and a bunch of ejecta goes out, and whatever didn't go away from Earth just orbited around, and that gathered together. But it was so hot that it lost its volatiles. It didn't get very much of the iron nickel, which is in the Earth's core, and the volatiles went away, and then you're left with the moon. And now we get to talk about isotopes. So,
There you go.
good question. That is the key question to what's coming up. Turns out that when they do the modeling, the moon would be 70% of the moon would be Theia, and 30% would be the Earth. So what you're left with is either, let's talk about the isotopes. Good segue. There we go. So when they take a look at the oxygen isotopes in the moon, the ratios are the same as on the Earth. So what are the isotopes? Oxygen, the chemical behavior of an element is caused by the electrons going around outside. And the number of electrons is equal to the number of protons in the nucleus in the middle. And so it doesn't matter how many neutrons, which are the particles which are kind of holding these protons together. Remember, protons all have a positive charge. They want to get away from each other. And the neutrons with the strong and the weak forces hold them together. And you can have different numbers of neutrons in a nucleus. And they change the mass of the element, but they don't change the chemical nature. The way that the electrons are flying around the atom is the same, whether you have a light oxygen or a heavy oxygen. Okay, so 300 kilograms of rock come to Earth. They measure the oxygen and the titanium and all sorts of different elements, and they come out, look at that, the same as on Earth. And believe me, there are about 500 steps between what I just said and where you get to that conclusion. It's a bit like polling for an election, right? You don't get to see the whole moon. You don't even get to see the whole Earth. So doing a whole bunch of measurements and modeling and such, then you get to say, this is what the bulk Earth isotopic ratios are. This is what the bulk moon isotopic ratios are. And lo and behold, they're the same. So, I just chose this paper. This is 2021. So, this is up to date. And what they saw is while the oxygen and titanium and chromium, that's what's on the left, are very, very similar, turns out vanadium is a tiny, tiny bit different. And so what these authors are suggesting is that the vanadium is going to be different on Earth than the impactor by a little bit. And then you get these averages after the collision, after the giant impact, because, so the impactor and the Earth started the same because they're all in the same nebular cloud, but because of differentiation in the Earth making the core, so that's the second level, the proto, that says the silicate Earth, I forget the B, doesn't matter. But the mantle around, so the blue stuff around the red stuff, can I get my mouse in there for you? Here we are. So there's the core of the Earth, there's the mantle, the vanadium is fractionated, and then comes the impact, and then the moon has the heavy vanadium from the Earth's mantle, and so there's that tiny little difference. Okay, so that's the sort of work that people are doing now. But then the most recent model is that, and it's still a giant impact, but this one came, instead of having a glancing blow, what Sarah Stewart says is, and she's one of those people who do these models of, they you impact two bodies and then you use a supercomputer and say what happens afterwards and all the fluid dynamics and things. So she and her team at the University of California, Davis, say, no, it wasn't a glancing blow. It was a full frontal blow, everything pulverized. And it created a synestia. Why synestia? Hestia is the goddess of the hearth. And a synestia is saying that when you get these big collisions, and she thinks they happen all over the place, then you get this kind of homogenization of all of the elements and their isotopes, and it makes this sort of donut. And then inside, so the Earth is now that whole donut, and she calls that a synestia. And inside that cloud of Earth stuff, first of all, the moon forms out in the annulus, in the donut, and then later on, the Earth reforms in the middle, and it's that extra time between the two that gives the Earth its extra iron, and it's much denser, and so it gets the volatiles, which the moon don't get. And then, just to show how up-to-date these are, this is a paper that was published a month ago. And I didn't put down the title. That was sloppy of me. Anyway, this is what people are working on now. And they say the old giant impact, they call the canonical giant impact, would not lead to the right isotopic signature of what a synestia would create. And so, I just want to say, it's still a very hot topic. There is no model that explains everything. It's kind of fun. And I really didn't know that, Lauri, when you set me the challenge of working at this. So I thank you very much.
Seems like rather a lot of
Randy,
work.
can those slides be available maybe somewhere?
Oh,
Because
absolutely.
I'd like to look at them again. This is too much new information for me. Too much to take in all at once.
I spent rather more time this weekend than I normally do on one of these presentations. But thank you. I really, really did enjoy it.
They'll be in the recording too.
And they'll all be in the recording.
Oh, it'll be, that'll be in there. So that's good.
Presentations. I will send it to you.
Okay, so hands up, anybody who knew about synestia or synestia.
Kirsten did. Good for you.
Good for you.
Where did you hear about it?
I heard it on a television program, one of the newer of the episodes of the season, How the Universe Works. I have about 70 episodes recorded. And they did an update on that. Yes, it's been in the popular kind of media culture. Yep.
She did a TED Talk. Sarah Stewart.
Okay. Have to look her up.
For
sure. Does anybody have any questions for?
Yeah, Gary's up.
Randy. Oh, Gary. Sorry. I can't see everybody.
Hi there, Randy. I see that Pluto is a planet denier.
You know what? I really don't care.
Oh, it's important. Pluto deserves to be a planet. But anyhow,
Yes, I agree.
when the satellite was approaching Pluto, it showed a very interesting video of Charon and Pluto spinning around a center of mass that was actually outside of Pluto. It looked rather odd. So while I was carefully listening to your talk, I looked this up, and it's called a barycenter or whatever. Guess where the barycenter for Earth and the Moon is?
Oh, what? About 100 kilometers from the center of the Earth?
4,000 kilometers from the center of the Earth.
No, really?
Yes.
That's right.
Look it up.
What?
How about that?
75% of the way to the surface, it says. So if we watched the very same video, the Earth would kind of look very strange going around a point that's 3/4 of the way out to the surface, which I thought was an interesting thing to share.
So is that, can you actually, if you couldn't see the moon, would you be able to know that the moon was there just from the wobble of the stars?
I have no idea. That's a good question, though.
That's cool.
And
So
maybe
we-
that's
Yeah.
what
The stars are too far away.
Uh,
From another
Yeah.
planet you could, but
The sun.
So we're actually going through space, kind of like a corkscrew.
no, I've seen this one. This is important. The shape of the sun, of the moon going around the sun is always convex. It never actually is concave. Like it's always, the curvature is always in towards the sun. And it would be even more so with the Earth. So if you were just to plot the orbit of the moon around the sun, it would be wibbly, but it would not actually ever weave in and out. It's
Okay. So
Pedersen.
the Earth must wiggle then a bit too, right?
yes. Sorry. Just say that again.
The Earth's orbit must wiggle a bit too then, going around.
Yeah, by 4,000 kilometers, it would go in and out
Yep. there you go.
4,000, which is really cool. I hadn't thought of that.
There you go.
Seasonally?
Well, you learn something new every day.
Every day, that's right.
Thank you, Randy. I'm not sure I'm going to be able to put that in much of that kind of evidence in my young people's program, but
No,
I
it's
wanted
a
to.
collision. The other three classes do not come close to explaining it. So it is a collision. It's just
Yeah.
whether it's a glancing collision or whether it is a very big splat.
Mhm.
Either a big splat or a very big splat.
You should really emphasize that science proves the moon does not exist.
Yeah, no, I'm not going to go there. No. Okay. Well, thank you, Randy, and I'll have to do some more work. Oh, I'm
Right.
sorry. Yes, go ahead.
We
Gotcha.
had a discussion last week, I think, that the Earth was pear-shaped. Could the pear-shapedness, meaning the northern hemisphere having less mass possibly than the southern hemisphere, have anything to do with that collision?
Okay. Yes, but not in the way that you're thinking. There is a paper that I was looking at this weekend saying that the core of Theia, the impactor, is stuck in our mantle, making this mass concentration, the one under India, the one under South America, which is what makes the pear shape. Nobody knows where that mass concentration comes from. And so the hypothesis in this paper is that's left over from the collision.
So the corpse is underneath South America and Asia then, say where the
Well, there are these two, when you take a look at the gravity of the Earth, there are these two very dominant mass concentrations, which give Earth its pear shape.
and perturb the asteroid for the satellite.
Yeah. Yeah, that's how they knew it. They knew it just from looking at
Looking at
Sputnik
satellite.
in the 50s. Yeah.
Randy, I'm kind of alarmed by the great weight that they put on this. Might be a significant number of rocks that came from the moon, but that is the whole representation of the moon itself. Or are they getting more information from remote sensing of other satellites that are orbiting the moon to get an idea of what the composition of the surface of the moon is?
Well, that's from the landers and the orbiters. They get the surface. But very important in this story, which I haven't gone into, is how much we know about the solar system because of looking at meteorites. So that is how we're sampling the rest of the solar system, is by looking at these little ambassadors of the rest of the solar system that come to Earth.
But I do remember back when they started orbiting stuff around shortly after Apollo, that they were mapping the mass concentration.
Yes,
of the moon
absolutely.
by mapping satellite work.
Mhm.
And it's not uniform.
No, and most of the mass concentrations are under the mare, which are all pointed towards the Earth. The far side of the moon doesn't have mare, and the near side does. Whole other big topic. Another day.
So where did Theia go?
Theia, 70% of it is in the moon and 30% of it's in the Earth.
Oh, okay, so it disappeared.
Yeah.
Absorbed.
I see Gary.
Okay, Randy, you're the scientist and I'm not, but I don't believe that the moon doesn't do a slight concave outward from the sun a bit when it's orbiting the Earth. Could you send me the proof of that?
I sure can.
Okay, thank you.
Can
Can
you tell me?
I can't figure out how to put my hand up, so I'm just gonna talk.
Oh, okay, David. You can just put your hand up like this and we'll see you too.
So a spinning body, which the Earth is, rotates around its largest moment, largest spin moment.
Well, it spins around its smallest moment. You have your maximum and your intermediate form the equator, and the pole is along the minimum moment of inertia.
No, it's where it's widest is perpendicular to the
Not
axis.
about the dimension, it's about the moment of inertia. Anyway, keep going.
Right. So anyways, I think it's the largest, you think it's the smallest, but either way. So what came first? The spin causing the bulge, or the bulge causing the direction of the axis of spin?
We're getting into the weeds here. I'll talk over it. No, it's wonderful. And the simple answer is the Earth has a moment of a angular momentum, and
Yeah,
it always go around the minimum moment of inertia, and then you get the centrifugal force around the maximum and intermediate. But we'll talk about this when people don't mind having
sure.
multisyllabic words, because it's not
Right. Yeah. Sometimes we do get into weeds. That's right.
Yeah.
Yeah. Okay.
I agree with you, David.
So I've got a couple of other people on our list for giving either some announcements or presentations, and I have got David Lee. Do you want to do your SIGS report?
Yeah, I hope, can everybody hear me?
Yes.
Oh,
Yeah.
excellent. I'm actually coming in through a browser right now. My my Zoom client said that it was not up to date, so I didn't want to scramble and update it. So anyways, I hope I've recreated everything. You can hear me. That's good. Yeah, okay, that's great. So tomorrow night, November 5th, I guess, we'll have the SIG meeting, and we're now operating on the new centrally administered distribution list. So if you have not received an invite for tomorrow night, then you're not on the list. So if you wish to be, let me know. Also, if you're on the list and you received it and you don't want to be on the list, let me know about that as well. So there's a couple of things I just wanted to mention, just for people, whether they want to decide whether they want to come tomorrow night or not, is that we're going to we developed a list of topics for the coming year, and I'll speak to a few of them. We'll probably be doing some segments on the RASC certificate programs, and I'll make some comments after the SIG announcement as well. And also NOVA. Lauri, I hope you don't have any post-traumatic stress from NOVA, but yes. I know that I know that Lauri has been working really hard on doing the final little bits and pieces of NOVA, and yeah, so we're probably going to attempt to execute NOVA in the coming year, maybe early year,
February and March. February and March. Yeah. So
Yeah. So description wise, it's meant to be kind of an introductory kind of program to astronomy. So we have some very kind of key topics, and we're going to do. Lauri, do you know who's going to present all the stuff?
oh no, we haven't got that far. We
Oh.
haven't even got dates yet. So that
Okay.
we'll get that. We'll get that.
I'm sure you'll be one of the presenters, and as well as I.
And we will invite people who kind of have some expertise on subjects to come and help us give some of the presentations, or at least partly some of the presentations that will be
Right.
done. It's going to be it'll be 6 weeks. We do two modules a week. And we'll be inviting the RASC members first. It really is for beginner or novice observers. NOVA is new observers to visual astronomy. That's what NOVA means for us. And so some of you are well beyond anything that we can probably give you in the course, but we'll have probably a total of about 20 people that will have take the course in the first part. And then we'll have more people if we feel that we can handle that. So we'll be inviting people from the RASC first, and then we can fill in around with the public or members of the FDAO. I'm sure there will be some people from the FDAO that might want to come as well. So we'll fill that up, and I've got an ask in to do it at the center. Because we've got the auditorium, we've got the planetarium, we have telescopes there for people to use. We have, we can go on a tour of the Plaskett telescope when we do the telescope part. So it's kind of a no-brainer, I think, to be able to have that. And so I'm asking for permission to use that. So we'll give you more information as things come along. But just put in the back of your mind if you're interested in a fairly new observer, then kind of put in the back of your mind that we probably will be doing that once a week for 6 weeks.
Great. Thanks, Lauri. And this is especially for people that are tired of watching the YouTube videos and not being able to ask the YouTube video questions.
Yeah.
So especially for you.
In person.
So there's a couple of other items too. We're going to do some general things about light pollution and sky brightness. And I'm actually hoping that we might get a guest visit from Reg to talk about weather. And we're gonna probably have maybe a segment on smart telescopes, because I noticed in the last few times on the emails that people are starting to buy smart telescopes. So that might be a kind of an interesting topic as well. Anyways, tomorrow night, if you didn't get an invite, as I said, just let me know. I'll make sure that you get the invite. And I think that's all I've got for SIGs. But I'd like to just spend just a moment, or did you want to leave this for what to do on a rainy night?
Leave that
Okay.
for another little
right.
bit. Yeah.
Okay, then I'm done.
Okay. Alex, do you want to give us your announcement or? Yeah.
I have to share the screen for Alex.
Okay.
So we were talking about particles last week. And what I'm showing you is called a diffusion cloud chamber.
A what?
Cloud chamber.
But what was the first word?
Diffusion.
Diffusion.
Diffusion, yeah. That's what it says. We did that lab in 2012. It was Physics 112.
Okay, you ready?
Yeah, I think so, yeah. Okay, that's the cloud chamber, and the big fat ones are the alpha particles. And if there's a thin, very thin, like a spider web, that is the beta particles. So the alpha particles are produced by is the helium nucleus, and the beta particles are the electrons.
So what are we looking at?
Those are the particles coming from that source.
No, but okay. So at the bottom
is that source. That's the radium. Radium, believe it's radium 226, half-life of 1,600.
Okay, so you're creating the particles down at the bottom.
Yeah,
and then what makes those
Those are the tracks.
In what?
You have a dry ice in the bottom. On the top is a felt, you put methanol on, and the temperature difference produces the tracks, which are caused by the ions. That's not the particles themselves.
Okay, and tell us why we're talking about this.
Because it was mentioned last week about we can't see particles.
Ah,
This is about the solar wind.
Yeah.
Okay,
And these are so note note that only the tracks of alpha and beta or beta birds become visible, not the particles themselves. Okay, and that was the experiment done years ago. We don't do it anymore.
So Alex, what are the
alpha
particles? Sorry,
yes.
Alex, what are the particles disturbing that leaves the trail? That's what I don't understand.
It's between the temperature difference, so it's highly condensed. Because you have
like a contrail from a jet wing or something.
Yeah,
okay. Okay.
It's causing the condensation of the
super concentrated because there's dry ice below. And there's the air temperature between, and on the top is a felt ring, and you immerse that with methanol.
Okay.
Huh.
Interesting.
question.
Yes. Yes.
Oh, yeah, just for David, there's asking what's causing the trail. It's as you were saying, Alex, it's a super saturated vapor of alcohol, and as the particle flies through it, it disturbs it and causes the condensation trail. So it's
okay. That's perfect. That's perfect. I wasn't quite sure because I know we can't see the particles, but we see what the particle does, right? It leaves that trail.
And then
okay,
it gets interesting when you put a magnet through it, because then you can actually see the charges on the particles, because they'll bend according to the magnetic field.
So Jim, you've seen this before then?
Yeah, I've actually tried to build a cloud chamber, and it's supposed to be really easy, but I never had access to dry ice, so I was trying to do it with a Peltier cooler, and then I tried it with some super cold spray, but didn't have any success with it, unfortunately.
Now, Alex, you're also using a microscope. Does that mean it's kind of small? You have to use a microscope?
Microscope. That was done by a camera.
Oh, it's a camera. Okay. Oh, okay. Yeah, it just looks like the eyepiece of a microscope.
Yeah. So he zoomed in, and then on the top is amber LEDs.
Amber LEDs. Okay.
Yeah, that's what I did.
So how big is this chamber? 10 centimeters, 7 centimeters. Okay.
Okay, now I get it. I know.
Also, we had some tin foil on the side. So if you put the source behind it, you will see the tin foil will stop the alpha particles, but the beta particles would still go through.
You don't have a picture of the apparatus, eh, Alex?
No, I can give you the actual one next time. How about that?
Yeah, that would be cool.
Hey, Jim, I was wondering what you're going to use for a source. This looks dangerous to me.
Yeah, don't be playing with radium at home. Yeah.
It's a very weak source. And I assume it's radium-226 and has a half-life of 1,600.
1,600 what? Seconds?
Half-life.
Years?
Yes, 1,600 years.
Oh, that doesn't sound good.
Oh, don't tell Marie Curie about that.
Yeah, right. I'm happy Jim didn't get it going.
Hey, thank you, Alex. That's really neat. That's really
it's a fantastic image too. It's aesthetically magnificent. Looks like a work of art.
Yeah.
I couldn't tell where you plug it in.
Okay, Peter Jedicke. Peter is coming to us from London, Ontario. How is London doing, Peter?
Oh, beautiful. It's been a nice, warm, overcast day today. I don't know. Well, you folks, of course, have the best weather in Canada, so I shouldn't try
Not today.
We had really high winds and rain and the whole thing today. So yeah,
It was
but
lovely. Anyway, I just want I have a one small piece which may be news. I don't know if you folks hear about these things on a normal basis or not, but there are 4 new asteroids named after persons who are associated with University of Victoria. So here they are, and these are all discovered by Dave Ballum, who probably most of you know. These names were just released either this weekend, I guess. So that's why I thought maybe you folks wouldn't have heard about it yet, but here they
no,
are. So I'll leave them up for a moment, and
fantastic.
if I may be allowed to promote something, on Friday of this week, Montreal Center and Kingston Center are co-hosting a Zoom event with David H. Levy as being interviewed,
Yes.
and the interviewer will be me.
Ah,
If anybody's interested in hearing David talk about his eclipse experiences and comet discoveries and so on, that's Friday in the evening Eastern time, so late afternoon for you folks on the West Coast.
David,
Where
could
would
you
we
leave
get
the
the
link in the
Yeah,
chat?
I think I have it, but I don't know where I have it yet. But it should be on like Montreal Center's Facebook page.
it's
Okay.
also in the RASC newsletter that came out today.
Yeah,
Oh
no,
yes, it is.
Yeah, yeah.
So,
Ah,
I know 2 of those names, but can anybody speak to who the 4 people are?
Absolutely.
Go for it.
Like Karun Thanjavar was the person who was the astronomy lab instructor for a number of years at the university. Was a terrific person who helped the RASC and the FDAO tremendously. He's just a wonderful person. I think Alex, you would have known him quite well in the physics department. He's a really, really nice person that really helped us out. Tim Venn is at the university, I believe she was actually the was not the director, what, the chair of the astronomy and physics department. Alex, is that right?
No. Nope.
No?
Oh, no.
Okay, sorry. Anyway, she's quite well known at the university. She has spoken to us a couple of times and is very well regarded. I mean, most of you might know James DeFrancisco, who is right now is the director of the HAA and up at the center, and is on our board of directors as a kind of a consultant, kind of adjunct person on the board of directors for us with the Friends of the DAO, and has done a huge amount for us, and he has helped a lot in getting speakers for us and keeping us on the straight and narrow. And then Dimitri Monin is the person who looks after the telescope at the center. So he along with Dave David oh, for heaven's sakes, help me out here, guys. Not Dave Balaam. He just retired. Oh goodness. Starts with a B as well. I'm sorry. I'll get back to it. He and Dimitri Monin are the ones who know more about that telescope than anybody. And Dimitri was the person who during the pandemic made it all robotic. And if we need anything, we just ask Dimitri. So these are 4 really fabulous people. I'm just so pleased to see their names there. Does anybody else have any other people know them in other ways? No? Okay.
Probably thanks to Peter for helping push these things through, because I know that you've had your hand in. No, not at all. Not this time.
No, not this bunch. This Dave Ballum, you know,
This is
is
Dave Ballum.
you guys know Dave, because he's the discoverer, he gets to enter these names himself.
Yeah.
I only just found about it through the public release of the new names that comes out basically once a month. And if anybody's interested in following those things on a regular basis, reach out to me and I'll tell you how to subscribe. I forgot, but it's there somehow.
So
Oh,
Lauri,
I'm so pleased.
you have
These are great.
you have a big rock named after you, don't you?
I do have a very little rock named after me.
So,
Actually, Dave Chapman in Nova Scotia just actually photographed it, and so I actually have the two parts that kind of show that it moved like slightly. And so I asked Dave Ballum to see if he could find it, but Dave Chapman found it first, so I have it now, so it's
Can
great.
bring that
Thank you.
image to, pending Astronomy Cafe, Lauri?
I beg your pardon?
Can you bring that image to us
Oh yes, I will. I'll put it up. I'll put it up on the no, I don't have it kind of right now, but I can put it up on the Rascals list. Chris Gaynor? Did Dave found yours yet? Chris Gaynor?
trying to unmute?
No, maybe he's not. Maybe he's just kind of not on. Yeah, because he says he and I kind of had it at the same time, so it's really fun. Oh, I think maybe we can we can write a little note of congratulations to these 4 people, because they are important in Canadian astronomy for sure, and they're right here. They're all right here. That's wonderful. Okay, and Dave Payne, you had something that you wanted to show us?
Sure, I was initially not going to speak at all in this session. That's difficult for me to do, but I did get a request for Randy to show.
Okay, just make sure you don't go into the weeds.
I'm going to try not to.
Okay.
I'm going to try and keep it very high level.
Should we do a timeout, David? We're getting into the weeds.
If you do that, that'd be very helpful.
Okay.
It's always a balance, right?
Yeah.
Okay, am I sharing that?
Yeah.
Yeah.
We can see it.
It's just
Beautiful.
Andromeda, and I'm just setting something up here. Because I was dissatisfied with the explanation of how stars form, particularly how they spring out of nothing, how they seem to spring out of this diffuse gas that's out there. So starting at a big scale, this is Andromeda, and I just want to point out the spiral arms in Andromeda. So the gas and dust in a galaxy like this doesn't follow Kepler's laws of motion. And it's because we're within, the gas is partly flowing within the mass of the entire galaxy. So it's not orbiting the galaxy, it's actually flowing within the entire mass of the galaxy. There's a very slight 0.1% of the total mass is in the center, but it causes a spiral effect because the gas has this viscous property. It's the same property that makes a terminal velocity on something drop. It counterbalances gravity, and in this case, it's taking the momentum, the spinning momentum, and dissipating it through its viscosity. And you can see where these bright red areas, that's where stars are being formed in the galaxy. And what this amounts to, it tends to be on the outer rings and it tends to be in areas of turbulence, like something has created eddies in the gas, and that spurs a lot of star formation. And why is that? It's because these eddies increase the density of the gas considerably, especially if the eddies are supersonic eddies. But in order to try and figure this out, that's as far as I'm going to go on star formation. But what I wanted to do is find out where the gas is and where the dust is. Are they in the same places? And what do these eddies look like? Now, these eddies are actually forming on all kinds of scales, right down to the molecule. But I can't see that scale with my camera, but I can on this scale. This is a molecular cloud, and it's got a bunch of dust and hydrogen, of course, but it's being backlit by the emissions of hydrogen. So what you see is the dust that's being backlit by this red mass of emitting hydrogen alpha. And we take these with narrowband, what I spoke about last week. We try to take these pictures with narrowband because they show different things than what you see in normal red, green, and blue colored light. So if I take my mouse off, what you see here is what you would see with red, green, and blue filters. And what it catches is a lot of reflections off that dust. So it's starlight that's hitting the dust and bouncing and seeing, and you see the reflections everywhere, and the dust turns a reddish brown color. Sometimes it's blue if it's a big blue star. It sort of takes on its reddish brown tinge. But if you zoom into some areas, there's some interesting features when you get into the nitty-gritty of these.
David, can you make this bigger? Ah, yes, you did. Thank you.
Yeah, I'm going to zoom in. But here we see a young stellar object sort of emerging from this L-shaped. So it's emerging from a dust-covered hydrogen cloud. And what that dust is doing, it's actually cooling the hydrogen gas within, and it's doing that through long wave radiation that we can't see. But at the same time, it's blocking any heating light from stars and other emissions that are going on in the background. So that's one of the things. There's a few other objects that are appearing that it's hard to see with the normal light, but are much more detailed when you go to the narrowband filter. And I think this is the one you wanted me to show, Randy.
No, this is not the same one, but it's great.
Okay.
The one that I put in the newsletter is not this photo, but this is absolutely wonderful.
Okay. I just put another one that's kind of along the same lines. It's just another view of a different object, but it's another one that really highlights the difference between taking an image in the narrowband actual emissions from the gas itself versus all the starlight as well as the narrowband emissions all mixed together. So this is a narrowband image. It really suppresses any reflected light, but you do get to really see the swirls that are occurring in the molecular cloud. and I can show that large. You can see this swirling dust. So what you've got is various concentrations of dust. It's not necessarily in the exact same place as the concentrations of hydrogen, but in order to get a star, you essentially have to have the hydrogen freezing on top of the dust and that whole thing amalgamating into a mass big enough so that it can start to attract other hydrogen molecules through gravity. So it's an intermediate stage between the cloud collapsing due to cooling and forming a mass that can start to then collect. And there's a lot of similarities in the research out there between the start of a star and how the planets form in a ring around a protostar. It's the same sort of flocculation, if you will, of dust grains into something with mass that can start to gravitationally attract hydrogen to it. And that's why some planets like Saturn is its core is described as a slush, if you will, between solid and other condensed gases. But anyways, when I go back to the RGB, it's equal. Oh, I don't know if I can zoom in on that. I think I got one here. When I go into the narrowband light, it's actually prettier in a way, because now we see a different sort of structure, because we got nice reflections of a new star here. We've got reflections on this, which looks completely different in RGB light, because we're mainly seeing the reflections off of it. Some things you still get that red hydrogen alpha emissions there, but you can see around a lot of the stars, we can see reflections creating these halos through the dust. And yet we still see the odd really dense set of dust in places. And just to show that it happens at all scales, if I zoom in here, you can see it's almost, this is really zoomed in, but it's almost like a fractal sort of geometry. So it's like a branch looks like a tree trunk, and so it's self-similar on very different scales. But here we've got some emergent stars, we got some swirling dust, and it's through this swirling and these eddies that are formed at all kinds of scales that has to lift the density of the gas from absurdly low density, very, very rarefied, to something that can actually create a new star. So hopefully I didn't see any of that.
Does anybody have any questions for
Just
David?
just
Those are just amazing.
just a comment about David. You mentioned fractal. You definitely see these patterns, right? And you're absolutely right; they occur at different scales. But the last one you showed looked like the horse head.
Yes, it's basically the same thing from another view, right?
Yeah.
The horse head is lit from behind, just like that backwards L-shaped thing I was looking at. Except the horse head happens to look like a horse's head, so people like that one.
Well done.
These are beautiful, David.
Thank you.
I mean, I know that, you'd rather have other people say something other than they're beautiful, but they really are. Yeah.
Well, I mean, part of the fun for me is I sort of sit there and I think about what's going on, and I try to figure it out as best I can before going into the weeds and the research. And then I go into the weeds of the research and I go, oh, okay, someone's been there before me, but that doesn't take away the fact that I thought about it.
That you did it. Yeah, that's right.
And I want to say, after last week, when Dave showed what was underneath the photo in Zenfolio, I started looking. And if people haven't taken the opportunity to look at what he's been posting, that each one is a really rich text explaining what he did, but also how to look at it with his specialty in fluid dynamics. And I think it's really cool. And I know you put a lot of work into that.
Yeah, it's just, and you can only say something about another picture, right? You don't want to keep it too long, so it's
That's good.
Maybe there's a book in there one day, I don't know.
I think so. I think so. Yeah.
Thanks.
Okay. Does anybody else have any other announcements or things that they would like to bring up at this time? I've just got one other thing that I'd like to just put forward.
Just a quick one.
Yes, Kirsten. I've
Announcement.
got Kirsten's hand up. Yep.
Thanks, Lauri. I just wanted to just give out a quick reminder. Appreciating that next Monday is a holiday, Remembrance Day. But I just wanted to give a quick reminder about the presentation up at UVic on the evening of Wednesday, November 13th. Starting at 7:30 p.m. We're going to have a presentation by Dr. Christian Marois, who is going to be giving us a great presentation about what's called the Habitable Worlds Observatory, which sounds very interesting. It's a conceptual mission at this point that through NASA. It would be a large ultraviolet optical near infrared observatory to search for and characterize habitable planets beyond our solar system, with an expected launch in about 2040. Its main objective would be to identify and directly image at least 25 potentially habitable worlds, looking for chemical biosignatures. So Dr. Marois is going to be talking about the current design and objectives of this conceptual mission, and excitingly, work that NRC may be doing to look at new technologies that could lead to a Canadian contribution to this mission. So it's one not to be missed. And that's at the Bob Wright Center, Lecture Theater A104. Thanks, Lauri.
Thanks, Kirsten. Did somebody else have a hand up or had said something? Yes, David, go ahead.
Okay, let me lower the hand. Actually, Reg and I have been kind of talking, and Reg, maybe you can comment on this, but there may be yet another opportunity to see the comet.
On Wednesday evening. The skies were clear tonight, but it was way too windy. And if the VCO is still standing, we were planning the evening. And the great thing about falling back is that it gets dark earlier, so we get to see the stars an hour earlier, and we can get home earlier as well. So
the comet is actually well past Ophiuchus now, so it just crossed over. So it might be interesting. The tail's shorter as well, but well worth seeing, I think. Yeah, thanks.
How many people have? How many? Put up your hand or thumbs up or something that if you've seen the comet.
Pretty good.
It's pretty high percentage, I think.
Pretty good. Yeah.
Well done.
Yeah, that's pretty good. Yeah.
How come
Well done.
no one ever says the name of the comet?
Chu Chan Shan.
Oh, good.
Yeah, Randy's not afraid.
Yeah, no, I couldn't have done that.
So Chris Pierce here had his hand up.
Chris, yeah, sorry, go ahead, Chris. I can't see you.
Just a quick thing to look out for your observer's handbook. Paul
yes.
Gray, a member of RASC Halifax, posted on Facebook today that he received his.
Hoo-ha.
So they've made it as far as Halifax.
And Peter Jedicke had his hand up.
Maybe he's got one too already.
Yeah. So it should be.
They
should be coming.
Further this far away, but they're supposedly coming. So.
And since we're doing announcements, no Astro Cafe on the 11th. It's Remembrance Day. We're still looking for hosts for the rest of the season. So do please volunteer. It's not onerous, and it's nice having fresh ideas like Lauri has had. So please, it's really, there's no preparation required. It's just we like to have different people hosting this event. On the 25th, 3 weeks from now, is the annual buy and sell. We will not be doing it hybrid. It will be in this room, in person only. Bring the your used equipment and put a price tag on it. And if it's the right price and the right thing, it's going to sell, because people are rather keen before the Christmas holiday.
And just a reminder, if you are bringing something larger or more expensive, please let us know ahead of time. So will you coordinate that, Randy?
Sure. Good.
Because
and then we can advertise that ahead.
Yeah, and then we can let people know, because it's probably best to pay with cash or whatever. But if somebody's selling something that's multiple $100, most people don't have that in cash.
But it's also good to get the hype up.
Yeah.
Yes, I can create a web page with a listing, so people that have lots of stuff, if they want to make a list, then we can put it all up there ahead of time so people will know what's available.
So big or small.
How do you want people to pay?
It's a one-on-one deal.
So. It's a one-on-one deal, yeah. So
okay.
probably
Whatever.
E-transfers as well, that's an option, right? But most people will want, most people don't take credit cards, so.
No.
I walked out with 3 telescopes last time. I got quite in trouble when Eva saw the back of the car.
And Kirsten, didn't you buy something at that last buy and sell that was?
Yeah, I bought 2 things, Lauri. Well, actually, no, I bought more than 2 things. I bought yeah, I did.
It's good to be honest.
So that's the 25th. You have 3 weeks to prepare.
So I just wanted to kind of do a little bit of something for the next a little bit. I don't want this to be long. I want this to be nice and short and snappy. Is that I was thinking of cloudy nights coming up, and we've got November, December, January, February, before we kind of get into the nicer months. And I was thinking, okay, so we all kind of need things to do and keep our interest and passion up. And so I was wondering if there were people that had something, and I was thinking of, like, for instance, we could make a little bit of a resource list for cloudy nights, as I kind of was I was kind of putting it that way. What you've been reading, so either in books or magazines or online articles online. If you've been listening to any podcasts that you've really liked, or if you've been watching any TV programs that have come up, or YouTube videos, or in other ways that you've kind of coming up against something that you think other people might be interested in. And what I'd like to do is, if you know of something, you could kind of throw it into the chat, or even if you just say, I've got the name of a book, but I don't have it right now, but I'll get it to you. So if you wanted to I just kind of let us know what you have. And I know that Natasha sent me something today that she wanted to pass on. And I think David Lee said that he wanted to pass on something. And I'm wondering if there's anybody else that just kind of off the top of their head a little bit would like to do some sharing. If there's anybody else that would like to think about that for a bit. Okay, well, I'll leave it to Natasha, if you'd like to kind of start us off and just give us that information, a little bit of what you gave me a little bit earlier, and then we can also put it into the chat as well, so people can do that.
Thank you. Thank you, Lauri. Yeah, so yes, your mention of that reminded me that last week Randy mentioned Dava Sobel's book about the glass universe, and that in turn reminded me of this excellent series that Dava did on BBC World Service. Can you see the screen? The Sun, Our Star?
Yeah.
Okay. So this is a series that she did in 2018, but I have listened to it at least twice. There are 5 episodes. I'll put the link to this in the chat box. So the first episode, etc. I'll just quickly go through here so you get a sense of what's involved. The ancient sun. So it's just a very holistic look at this series, and yeah, I will put the link in the chat box.
So these are all like podcasts?
Yes, they're 20-minute podcasts. That's right. Yeah.
Well, they look
just
good.
putting the link in there now. I seem to remember, Joe, many years ago, didn't Dava make a presentation? Wasn't she here in town and made a presentation for RASC?
Yes, she did.
Do you remember what
How
year
long
that
ago was that, Joe?
It was a long time ago, so I would have to go and look it up.
I think that's before taping of these kind of programs.
It
right?
was, yes.
It's pre-Zoom, I think.
Yeah.
Yes.
I really enjoy her books. I've read several of them now. I loved Galileo's Daughter and Longitude. Have you read
the new
such
book?
a good one.
Have you read the new one that Reg talked about last week? I don't know, Reg, if you knew the title or not. It's about Marie Curie.
Oh, it was
the new one.
It was on that list that Natasha
okay.
just showed right at the beginning there. Yeah. I would pick up another book by her absolutely any day to read for sure. And if you haven't read her, take a little bit of time. She really has done a very nice job. She does a lot of research.
It's also a pleasure to listen to her voice. This series that she did it's a wonderfully, almost relaxing experience to listen to her. She has such a wonderful enthusiasm and a way of, like, from my perspective, is public outreach, how she raises these complex ideas in a simple way that grabs people.
Oh, thank you. I love listening to podcasts when I'm doing other things, and we'll do that. That would be great. David, you had something else you wanted to
say that
you looked at?
I just wanted to comment on something that's been happening with my little journey in astronomy. I've been so inspired by the beginners group. They do more for me than I do for them, I think. So I actually recently I've been kind of inspired by Jill and and Brenda and the different people that have been doing, and Kirsten, doing all these certificate programs. I have actually never done one, and I'm probably one of the oldest members in the Victoria Center. So I decided better late than never. So here, let me just do a share here. So this is the webpage on the National for all the different programs, and you can see them here. Now, I picked visual programs. I believe there are some that have to do with imaging, but I really wanted to get back to visual observing. So I thought I would do the Isabel Williamson Lunar and the Double Star one. So those are the two that I picked. And here's the reference to cloudy nights. So the I think on Friday, last Friday, I started kind of looking, and I thought, oh, I should probably look at what the requirements are and what kind of prep I'm going to need to do, right? So I started looking at it, and these are such well laid out certificates. If you go down in this one, now this one is by Blake Nancoro, and he recently passed away. But I wanna just say how wonderful this is. Really a reflection of Blake as well. I don't know how many people knew Blake through the stellarium training and things, but he truly is a professional trainer, and actually technically he actually was. But he had it so well laid out, and I looked down here, and they have these resources as well. So this is the one comment I'm going to make. I have rediscovered a tool that I've recommended to many people. It's called Sky Tools, and I don't know how many people actually use it, but it's a remarkable tool for sort of creating plans for observing. So I just want to show you this. The lower part of the page has these downloads, and look at this. There's one for Sky Tools, there's one for Sky Safari, and one for Stellarium, one in Excel, and actually one in PDF as well. So I took it upon myself to try all these things. So I use Sky Tools, and I definitely use Sky Safari. So I have, it wasn't really readily obvious how to do these things, how to get them in to the tool. So if you want to know, just send me an email and I'll tell you how to do it. I know Kirsten was scratching her head about how to get some of this into Sky Tools, but I figured it out. So if you want to know, you can certainly ask me. And here's I'm just going to show you. This is Sky Tools, and it's a wonderful program. And Kirsten, jump in. I know you recently acquired this, but I really love it. It's kind of a log, and also it keeps your observations as well, so you can actually record your observations. But it's got this plethora of information. You can sort it. You can actually hit plan. It'll actually create a viewing order for you for a given evening. And they just added a feature called transparency. So you can actually put the transparency in to see if you're likely to see the object or not. So it's a wonderful tool. I'll leave. I'll leave. You could probably, Joe, you could probably find the reference, or I'll just slip this into the chat if people want to check it out. Do you have any comments, Kristen? You're a new user of Sky Tools.
Yeah, thanks, David. After your recommendation, because one of the things that I was, I use it particularly for making double star observation plans, but I also use it for planning out for Messier object observation as well. And a couple of things on it, because where I was really kind of scratching my head was, if there was a way that I could tell what an object or a target would look like through my telescopes, and I've got a couple of different kinds, but checking sort of the before and the after, like to confirm that what I actually saw through the eyepiece actually was in fact the correct object. And because a lot of the atlases for double stars or for other objects, they're just not, from a star hopping perspective, and I'm a star hopper, I'm not a go-to person, I star hop. The atlases in written form are good to kind of lead you to how to find something, but they're not detailed enough normally to confirm that you actually truly saw the object that you were after, whereas Sky Tools is. And it's actually technically detailed enough that you can tell it what telescopes and equipment and eyepieces you have. You can program all that in, and it will visually generate what an object will look like with that combination of equipment. And you can correct for whether you've got like an Amici prism or you know, a dialectic or a mirror diagonal, or if it's a daub or whatever it is. I mean, it'll account for all that, so it'll get the orientation correct. And so yeah, it's an incredibly valuable tool. So similar to David, I guess, I've been doing a ton of reading around that, like just familiarizing myself with tool. And yeah, there's probably more I could say, David, but yeah, I think you're right. I mean, the other thing too is it sorts by time. So it'll tell you like what you can see starting at certain times of the night. So, if something's not visible until like 4 a.m., it'll tell you that. So yeah. As well as its visual difficulty, is it an easy target to see? And the magnification required to see it as well. So it's brilliant.
I was truly relieved when I loaded the RASC double star list and I saw obvious and easy in the difficulty. So yeah, so that's what I've been busy doing. I also want to let people know that the world doesn't have to be totally digital, but it can be sort of a hybrid of those two things. So I also like the fact that Blake had put in a bunch of kind of book kind of references. So I have a couple of, this has actually helped me dust off a lot of my books in my library because I have many, many books on double stars. And I did start this endeavor probably 10, 15 years ago, but things got busy and I went on to other things. But I'm really happy that I'm going to go and pursue this again, because as I've been reading through it, going through the list and actually researching the pieces. So this is the other thing about cloudy nights. There's no reason why you shouldn't prepare. In fact, you should prepare before you go out and observe for various reasons. I mean, Kirsten's quite right. You want to make sure you nail the right thing. You don't want to look at something and thought, oh, I saw it, and you actually didn't see it. So some of these things are extremely tightly separated, like they're very close to each other. Some are really wide. So that, you know, in some ways, some are deceiving because they're so wide and you think, oh, where's the double star? Well, it's over here, right? Because it's quite a wide separation. So anyways, have fun researching on your cloudy nights.
Thank you, David. Thank you, Kirsten. That was really fun. That's something I haven't used, so I would have to go into that. Is there anybody else that has got something that they either have been reading or would like to share at all?
I listen to two different podcasts.
Go ahead, Randy.
Called Astronomy Cast with Fraser Kane, who's here on Vancouver Island, and he always interviews Pamela Gay, who is a very accomplished astronomer at the Planetary Science Institute. And they have a good banter back and forth, and they've been doing this. They're up to episode 750 or something like that. They've been doing it for years and years. And they talk about one little subject, but they do it in a way that I find very accessible, and they're very keen on space missions, and they will then go in depth into various aspects of astronomy. I've learned so much from them. And then the other one is the Canadian one called the Real Astronomy Podcast, I think it's called. Yeah. And it's just these two guys, and Bill Weir knows them quite well, and they are mostly talking about observing. And it's kind of fun having a good Canadian perspective on what's visible and complaining about the weather.
Thank you. Did anybody else have anything that would like to share? If not, maybe you'd like to think about that for a little bit, and we could come up with something. Maybe I'll make a little bit of a list of these, and I mean they'll be on the cast here, but we can make a little bit of a list and put that, where would be a good place to put that, that resource list?
Should we
Joe,
put it
where would
on,
be a good place?
yeah, maybe on the website. We used to
Oh,
have a
on the
resource list.
yeah, we could do that.
And Joe, I just dropped the URL into the Sky Tools reference.
Okay.
Something.
Okay.
Kathy
Is there
here.
anything?
Yeah, Lauri, I was just gonna ask, when you guys were talking about the NOVA,
Yes.
it's 6 weeks or whatever, 3 weeks or whatever, how do you get into it?
Well, once we get the dates and times and things all settled up, then we will put it out on the newsletters, like newsletters and on Facebook and things like that, and just get people to sign up. I think we're probably going to be doing it in-house here. There will be a fee that will be part of it, because we will have to have some expenses.
Commissionaires and stuff, right?
It could be, yeah, yes, we'll have to have a commissionaire. Well, we want to, feed you a little bit every night and have some resources and printing and things like that we'll have to pay for. But we'll get that information to you. I'm hoping, I would hope that we would have something out before Christmas, so that that you'd be able to kind of do some planning on that for sure. So
Okay,
we'll make sure everybody knows. Yeah.
that's good.
Okay. Well, if there's nobody else that has got anything, I think we can probably make that a night. Thank you to everybody for coming and for being part of our program. And if there is anything else that anybody would like to add to the resources list, maybe just fire me a little email at roche.lauri@gmail.com. Lauri with an Lauri, no E. It goes to somebody else if there's an E on the end of that name. So, but you can hand me that, and then we can get something going on that. Okay. So if that is all for now, I'll say good night to everybody, and thank you for coming on board here tonight. Thanks to everybody at at Fairfield. And we'll see you in 2 weeks. We'll hopefully up at the university on the 13th, but then we'll see you in Astro Cafe in 2 weeks' time. Okay,
Thank
goodbye,
you.
everybody.
Bye.
Bye-bye.